Hello everyone. Today we'll be discuss a lecture on Heisenberg uncertainty principle. So we know it is the most profound concept in modern physics, the Heisenberg's uncertainty principle, which is proposed by Werner Heisenberg in 1927 after the proposal of de Broglie hypothesis. So, why this concept came and what is this basics of this uncertainty principle will be discussed today. Myself, Dr. Anima Ghosh, Associate Professor of Physics from India. So, we know in classical physics, it is assumed that we can measure both the position and momentum of a particle with a complete accuracy. So, if we know the particles like mass and its velocity, we easily can find out position, momentum, and it's related to the particle physical properties. However, when we move to the microscopic world of atoms and electrons, this assumption no longer holds true. Heisenberg shows that there is a fundamental limit to how precisely or up to how certain limit we can precisely certain parameters of physical quantities can be known simultaneously. So this principle is not due to experimental error, but it is an inherent property of nature. So this Heisenberg principle, this is not of experimental error, it is the inherent property of nature. So the Heisenberg principle states that it states that it is impossible impossible to determine I'm writing again it is impossible to simultaneously determine. Determine the exact position and momentum momentum of a particle with absolute precision. So it is impossible to determine precisely and simultaneously the values of both the members of a pair of physical variables which describe the motion of an atomic system. So let's give some example of to understand this that so let us see some example of this. that according to principle, the position and momentum of a particle, let's say here consider the for case of a electron, cannot be determined simultaneously that with to desired degree of accuracy. So let's taking it that delta x, that is the error in determining the position. Error in position, and delta p, that is error in momentum. Momentum at same instant. These quantities are related as delta x into delta p, that equal to h divided by 2 pi. So this product of two error is approximately the order of Planck's constant. If delta x is small, then delta p will be large, and vice versa. It means that if one quantity is measured accurately, the other quantity becomes less accurate. Thus, any instrument cannot measure the quantity more accurately than predicted by this Heisenberg uncertainty principle. So this is Heisenberg uncertainty principle or indeterminacy. The same relation holds for energy and for holds for the energy and time related to this formula. That let's say that energy error is delta E, and we are measuring it with error in delta t time, then this equal to h divided by 2 pi. So this is the relation of uncertainty with energy and the time. So according to actually classical ideas, it is possible for a particle to occupy a fixed position and have a defined finite momentum, and we can predict exactly its position and momentum at any time. But according to uncertainty principle, it is not determine the accurately exact position. It is always come with a probability. So the simultaneous values of position and momentum of a particle at any time we define generally with the probability. So Heisenberg uncertainty principle implies that any physical measurement probability takes place and exactness such as momentum, and which are impossible according to classical ideas, may find a small but finite probability of accuracy. So we can have a simple example of determining the position with X-ray microscope. That if we just see the example, that determination of position with X-ray microscope. So let us say that this is our microscope object, and we are seeing this. This is X. So this is the microscope objective, and this is A and this is B. So two rays is there, and here it is photon, and here you can see that electron. So this error in measuring and these two angle is theta. Then suppose we try to measure the position and a linear momentum of an electron using an imaginary microscope with a large, very high resolution power. So the electron can be observed if at least one photon is scattered into the microscope lens. So if so, the resolving power of the microscope, we can see that by the relation delta x is equal to lambda divided by 2 sine of theta. So here this delta x is the distance between 2 points which can be adjusted by resolve the microscope, and this is the range where the electron would be the visible when distributed by the photon. And then we can find out the momentum, that component of the momentum along this, let's say this is the OA this path, and so that momentum will be h by lambda sine of theta, and this is along OA, and along OB it will be h by lambda, it will be the sine theta. So using the uncertainty principle, if we find out the total the momentum error in x direction and y direction, then we can add it, that delta px, that will be basically this minus of this. That means we can say that it will be equal to lambda divided by 2. I'll be erase it and write it again. So we can find out the delta px, that is equal to this is equal to h divided by lambda sine theta and minus h divided by lambda sine theta. So this equal to twice h by lambda sine theta. So if we find out delta x into delta px, lambda by 2 sine theta, what we have find out earlier, plus 2h lambda into sine theta, this equal to h. So we can write at h by 2 pi. So a more sophisticated approach will show that delta x and delta p get are equal to h by 2 lambda. So it is clear that the process of measurement itself perturbs the particle whose properties are being measured. So if we conclude that Heisenberg principle implies that in physical measurement probability takes place of exactness, and such phenomena which are impossible according to classical ideas may find a small but finite probability of occurrence. So today is up to this. Thank you very much for watching my video. So please support my channel. Please like and subscribe my video channel. Thank you very much.